Hey everybody, welcome back to Trigonometry. Today we're in section 2.4 talking about solutions and applications of right triangles. In this section we're going to talk about solving right triangles, and we'll also learn about angles of elevation and angles of depression, and we'll solve a few word problems. Here we go. So we're going to start by learning how to solve right triangles. So to solve a triangle means to find the measures of all the angles and sides of the triangle. Now when you're asked to solve a right triangle, of course you'll always know that the right angle is 90 degrees, and then they have to give you two other pieces of information. They either have to give you an angle and a side, or they have to give you two sides. So if you're looking for a missing side, you have two tools that you can use. One is the Pythagorean theorem, but in order to use the theorem, you'll need to already know the other two sides, or you can use a trig relationship. And then if you're looking for missing angles, one way is to subtract the known angles from 180 degrees, but of course in order to do that, you'll need to know the other two angles first. And the second way is to use a trig relationship with an inverse function. We're going to do examples of all of these. And sometimes there's only one of them that can be used in a particular situation, and other times you'll have a choice. But in that case, it's always good to know what your choices are, right? Now, one problem that we run into when we're solving right triangles or when we're working word problems is that if we find an answer and we round off, and then we use that rounded off answer to find another answer, then we have rounding on rounding, and sometimes the rounding errors can add up and throw us way off the correct answer. So to maintain accuracy, always use the given information as much as possible. In other words, if you have a choice between using a method that uses given information or using a method that uses a previously calculated answer, you want to stick with the given information as much as possible. But if you have to use a calculated answer, avoid rounding until the final answer. So what I'll do is, if I know that I'm calculating a number that's going to have to be used later in the problem to calculate another answer, then what I'll do is I'll keep a few extra decimal places so that I don't have my rounding errors compounding. So before we start solving, the first thing we need to do is get used to how these triangles are always labeled. In a right triangle, the sides are always labeled with lowercase letters, and the angles are always labeled with capital letters. So you can see that here. Notice that a side is always opposite from the angle with the same letter. So for example, angle capital A is opposite from side lowercase a. And the same is true for B, and the same is true for C. And the right angle is always labeled with the capital C, and the hypotenuse is always labeled with the lowercase c. And if we do it that way, our Pythagorean theorem, a squared plus b squared equals c squared, is always going to work. And now we're ready for example 1. So it says solve right triangle ABC if angle A is 34 degrees and 30 minutes and side C is 12.7 inches. So we'll need to draw ourselves a diagram. And honestly, you can turn your right triangle any way that you want to. I'm going to draw mine like this. And I'm going to label the angles first. So I'm going to call this angle A, and that means this will be angle B, and this will be angle C. And then I'm going to label the sides. So we know that the sides are always labeled with lowercase letters, and the matching letters will be across from each other. So if I go opposite from angle A, this is going to be side A. So this is lowercase a here. Opposite from angle B is here, so that's going to be side B. And of course the hypotenuse is always side C. Now angle A we know is 34 degrees and 30 minutes, and side C we know is 12.7 inches. So now it's our job to find the missing angle B and also missing sides lowercase a and lowercase b. The angle is going to be the easiest, so let's start with that. Now we know that all three angles in a triangle have to add up to 180. So we know how to find this missing angle, but it's even easier than that with a right triangle, and we've talked about this before. In a right triangle, 90 of the degrees are here in the right angle. That means these other two angles just have to add up to 90. And so to find angle B, I'm going to say that B is 90 minus the 34 degrees in 30 minutes. And you can do that on your calculator, and you'll find that B is 55 degrees in 30 minutes. Now I'll just throw in here that if they give you an angle in degrees, minutes, seconds notation, then you're expected to provide any other missing angles in degrees, minutes, seconds notation. But if they give us an angle that's in decimal degrees, then of course we can provide the other angle in decimal degrees. It's pretty much just about answering the question in the same way that the question was asked to you. Okay, now what's left is side A and side B. We could find either one with the information that we already have, but let's start with side A. Now remember, when you're finding a missing side, your two choices are whether to use the Pythagorean theorem or to use a trig relationship. If you're going to use the Pythagorean theorem, you have to already know two of the sides. We only know one side. So I'm going to use a trig relationship. So a trig relationship always involves using one angle and one side, and that information was given in the problem. So I was given the 34 degrees in 30 minutes, and I was given the 12.7 inches for side C. So if I think about angle A, side A is opposite that, and side C is the hypotenuse. So the two sides we're dealing with here are opposite and hypotenuse, and that makes us think of the sine function. So now we're going to write the sine of 34 degrees in 30 minutes is equal to opposite over hypotenuse, which is A over 12.7. And we just need to isolate the A. So we're going to multiply both sides by 12.7, and that will cancel those out from the right side. And so now on our calculators, we can multiply 12.7 times the sine of 34 degrees in 30 minutes, and that will give us a value of approximately 7.2 inches for side A. Now notice here that I rounded my answer off to 1 decimal place because the other side that they gave was rounded to 1 decimal place. So that's not exactly the rule, but that's pretty much how it works for us. And again, when you're doing your homework in MyLab, they will always tell you how many decimal places to keep in your answer. And now to find side B, we have a choice. We now know that side A is 7.2 inches, so we know two sides, and we could use the Pythagorean theorem to find side B. But remember, it's always a good idea to stick with information that was given in the problem as much as possible. So I'm going to find side B the same way that we found side A. I'm going to write a trig relationship. So I'm going to use angle A again, and this time, since I'm looking for B, I know that's the side adjacent to angle A, and still side C is the hypotenuse. So adjacent and hypotenuse makes us think of the cosine function. So now we're going to write the cosine of 34 degrees in 30 minutes is adjacent over hypotenuse, so that's B over 12.7. And again, multiply both sides by 12.7 to isolate the variable. And we have B equals 12.7 times the cosine of 34 degrees in 30 minutes. If you enter that on your calculator, you'll find that B is approximately 10.5 inches. So now I want to give you a little safety net and show you how to check your answers on something like this. Because we have not used the Pythagorean theorem yet to find any of this information, we can use it now as a check. So we have a right triangle here. So that should mean that 7.2 squared plus 10.5 squared equals 12.7 squared. Now I used the approximation symbol because it won't be exact. These two numbers, the 7.2 and the 10.5, have been rounded off. So the two sides are not going to be exactly equal, but we just want to make sure that they're pretty close. So on our calculators, let's check what 7.2 squared plus 10.5 squared is, and I got 162.09 there. And then on the other side of the equal mark, 12.7 squared comes out to 161.29. So you can see that they're a little off. Again, that's caused by the rounding that we did here and here, but that's okay, they're in the ballpark. If I had gotten, I don't know, say 158 and 161, maybe I would have felt like there was something wrong. But here, these two values are close enough for me to believe that the difference is caused by rounding. Okay, in example 1, the given information was one angle and one side. Here in example 2, they're giving us two sides. So this one says solve right triangle ABC if side A is 29.43 centimeters and side C is 53.58 centimeters. So again, let's draw ourselves a right triangle. Doesn't have to be fancy. Now I've got one side here that's obviously shorter than the other two, so I'll call this one side A, and that means that this side is B and this hypotenuse is C. And if this is side A, then this is angle A, and this would have to be angle B, and this is angle C. All right, now, side A is 29.43 centimeters. Side C is 53.58 centimeters. So in this situation, it seems like to me the easiest thing to find first would be side B, and we can do that using the Pythagorean theorem. Now we know that we're finding a leg here, so we know that we're going to have to subtract the squares. So I'm going to write B squared equals 53.58 squared minus 29.43 squared. So on the calculator, I can find this value, and now I know B squared is 2004.6915. Okay, now I've cut to the calculator because I want to make sure you know the easiest way to get a square root of a number. So I've entered here my 53.58 squared minus 29.43 squared, and when I hit equal, there's my 2004.6915, and I need to do the square root of that number, so I'm going to hit second square to do the square root function. But now I don't want to have to type that number back in. For one thing, it's clunky to have to write it down on paper and then type it back in. For another thing, it just leads to mistakes. Doesn't the calculator remember that number? And the answer is yes, it does. So notice down here on the bottom row, the second function of the negative key is ANS, so that's the answer function. So we're going to use that whenever we want to recall the last number that the calculator came up with. So to use it, of course, it's a second function, so we go second and then hit that button, and so now your screen should say square root of the previous answer, and you hit equal, and there is our square root. So now I've taken that answer from the calculator and rounded it off to 2 decimal places because the two given sides had 2 decimal places. And now we're ready to find one of our unknown angles, so let's start with angle A. And of course, we only know the right angle at this point, so we will have to use a trig relationship to find our first unknown angle. And so let's look at our diagram and think about the two sides that we were given in the problem. So coming from angle A, we have side A, which is the opposite, and we have side C, which is the hypotenuse. So of course, opposite and hypotenuse make us think of the sine function. So we're going to write the sine of angle A is equal to opposite over hypotenuse, so 29.43 over 53.58. And now we know how to handle this from section 2.3. We know that we can restate this in inverse form. So we can write the sine inverse of this fraction is equal to angle A, and that's exactly how you'll enter that in your calculator. So second button, then sine, so you have sine inverse, and then 29.43 divided by 53.58, press equal, and then you've got your angle, which is approximately 33.3 degrees. And now we could do the same type of thing to find angle B, but what I'm going to do in this case is just say that A and B have to add up to 90, so B is 90 minus 33.3, so B is approximately 56.7 degrees. And that's it. We have found our 3 unknown values. Okay, now we're going to move on to word problems, and so we need to define a couple of new terms here, and one is the angle of elevation. So we know that the word elevate means to raise something, so the angle of elevation is measured up from the horizontal. So you've always got a horizontal in view here, and the angle of elevation goes up from that. And then the angle of depression is measured from the horizontal down. Now it's a positive angle, so they've got the direction showing this way. But the important thing to remember is that the angle of depression will be measured from below the horizontal. Now, like I said, we are about to get into some word problems, so let's get just a general strategy here. So step one, whenever you're trying to solve a word problem in trigonometry or any other word problem, the first thing to do is draw a sketch and label it with the given information. And whatever quantity you're looking for, you need to label that with a variable. The thing you're looking for has to have a name. You have to name it something. You can decide what to name it, but don't just leave it blank, because if you leave it blank, that makes it really hard for you to use it in an equation. And that's our next step. After you've drawn the sketch and labeled the unknown with a variable, then you want to use the sketch to write an equation relating the things you know to the thing you're trying to find out. That's why your variable needs a name. And then in step 3, of course, you just want to solve the equation. And then check that your answer makes sense in the original problem. And here's where it's a good idea to go back to the sketch that you drew and compare your answer to the numbers in the sketch and see if it makes sense. So here is example 3 for us. This says, at a point A, 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees and 40 minutes. Find the height of the flagpole. Round your answer to 1 decimal place. So of course we need to draw ourselves a flagpole, and we know that there's a point on the ground 123 feet from the base of the flagpole. So I've drawn the ground here, and we'll label this as 123 feet. The next thing it says is the angle of elevation to the top of the flagpole is 26 degrees and 40 minutes. Now we know that the angle of elevation is measured up from the horizontal. So here is our horizontal. The angle of elevation is up from here. So when I draw a line from the ground to the top of the flagpole, I know that this is the angle of elevation right here. So this is our 26 degrees and 40 minutes. And we are asked to find the height of the flagpole, which is right here, but I need to give it a label or a name, so I'm just going to call it H for height. Okay, now let's think about how the two involved sides are related to the angle that we know. The 123 feet is adjacent to the known angle, and the H, which is what we're looking for, is opposite the known angle. Opposite and adjacent makes us think of tangent. So let's write the tangent of 26 degrees and 40 minutes is equal to opposite over adjacent, which would be H over 123. And so now we need to isolate the H. So let's multiply both sides by 123, and that will divide out from the right side. And now on your calculator, 123 times the tangent of 26 degrees and 40 minutes equals, you should get H is approximately 61.8 feet. And if we come back over here, 61.8 feet is a believable height for the height of a flagpole. And so I feel pretty comfortable with that answer. Now here's example 4. From the top of a 210-foot cliff, David observes a lighthouse that is 430 feet offshore. Find the angle of depression from the top of the cliff to the base of the lighthouse. Round your answer to the nearest degree. Okay, so we know that we've got a 210-foot cliff involved. Let's just draw ourselves a cliff. And we know that this cliff is 210 feet high, and we know that this cliff is on the water, and there's a lighthouse over here. It says 430 feet offshore. So that distance is 430 feet. Now it says find the angle of depression from the top of the cliff to the base of the lighthouse. So we know we're going to have a line, an imaginary line, going from the top of the cliff to the base of the lighthouse, but it says find the angle of depression. Now a common mistake here is that students will sometimes think the angle of depression goes right here, but of course it does not. Remember, the angle of depression is measured from the horizontal, so we need to get another little imaginary line here, and the angle of depression will be between this horizontal line and the imaginary line between the lighthouse and the cliff. So right here is your angle of depression. Now you'll notice that we have a right triangle here. By the way, we get to assume that the face of the cliff is straight up and down, and so this would form a right triangle. So one thing that we can do is say that this horizontal line and the level of the water form parallel lines. So this angle is equal to this angle. We could call this angle theta, and then we could find this angle and know that it's equal to our angle of depression, which is what we're really after. But another way of looking at it is to draw an imaginary vertical line here, and that puts our angle of depression inside this imaginary triangle. And we can know that the vertical side is 210 feet because that's the same as the height of the cliff, and we can know that this horizontal side is 430 feet because that's the same as the distance offshore. And now let's look at what we've got. So coming from here, which is the angle that we want to find, we know the side opposite and the side adjacent to that angle. So opposite and adjacent makes us think of the tangent function. So we're going to write tangent of theta is equal to 210 over 430, opposite over adjacent. And now, of course, to find out the angle, we need to restate this in inverse form. So if the tangent of theta is this fraction, that means the tangent inverse of that fraction is equal to theta. And you know how to enter this in your calculator, so you'll just go second function, then tangent button, and then 210 divided by 430 equals, and rounding to the nearest whole degree, we get theta is approximately 26 degrees. And let's do another word problem together. Here's example 5. It says an airplane is flying 10,500 feet above level ground. The angle of depression from the plane to the base of a tree is 13 degrees and 50 minutes. How far horizontally must the plane fly to be directly over the tree? And we want to round our answer to the nearest 100 feet. So as usual, drawing a sketch is going to help us know what to do. So we know there's an airplane. Here's my little airplane. And we know that it's 10,500 feet above level ground. So here is my ground, and I'm going to label that height as 10,500 feet. And then it says the angle of depression from the plane to the base of a tree is 13 degrees and 50 minutes. So there's a tree out here. Here's my tree. And there's an angle of depression from the plane to the base of the tree. So let's draw that imaginary line right there from the plane to the base of the tree. And we know that the angle of depression is 13 degrees and 50 minutes. Now remember, angle of depression is measured down from the horizontal. So if we imagine this horizontal line here, that angle of depression is right there between the horizontal and the line between the two objects, 13 degrees and 50 minutes. Now we're interested in finding the horizontal distance that the plane has to travel to be right over the tree. So let's draw that imaginary vertical line right there. And you can see that we've got a right triangle closed in. We know it's a right triangle because this is a vertical line and this is horizontal. So that has to be 90 degrees right there. The length of this side is the distance that we're interested in finding, so I'll call that D. This height here is the height that the plane is flying at, so that's 10,500 feet, and that's the length of that vertical side. And so now let's see what we've got. We know this angle right here, this 13 degrees and 50 minutes. And the sides that we have are the side opposite from that angle, and the side adjacent is what we're trying to find. So opposite and adjacent, again, makes us think of tangent. So let's write the tangent of 13 degrees and 50 minutes is equal to opposite over adjacent. So that's going to be 10,500 over D. Okay, now we need to isolate D, but it's in the denominator. So I'm going to start by multiplying both sides by D. That will cause it to divide out on the right side, and we're left with D times the tangent of 13 degrees and 50 minutes equals 10,500. And so now we're ready to isolate D, so I'm going to divide both sides by that tangent value, and it will divide out from the left, and it leaves D equals 10,500 divided by the tangent of 13 degrees and 50 minutes. So you can enter that in your calculator, and you'll get D equals 42,641.2351. But remember that they said round your answer to the nearest 100 feet. Now the hundreds place is right here. Remember 42,600, so this is the hundreds place, and we want to round to the nearest 100. So we look at the next digit. It's not big enough to make the 6 change to a 7, So we'll leave it a 6, and our final answer is going to be approximately 42,600 feet. And I've just got one more example to do with you. So here is example 6. It says the angle of elevation from the top of a small building to the top of a nearby taller building is 46 degrees and 40 minutes, and the angle of depression to the bottom is 14 degrees and 10 minutes. If the shorter building is 28 meters high, find the height of the taller building. Round your answer to the nearest meter. So, of course, again, we need a sketch. And we're going to start with this small building. So here is our small building. And it says the angle of elevation from the top of a small building to the top of a nearby taller building is 46 degrees and 40 minutes. So here's our taller building. And let's get our angle of elevation. It says from the top of a small building to the top of a nearby taller building. So we'll draw this imaginary line here. And then it said the angle of elevation for that was 46 degrees and 40 minutes. So we need a little imaginary horizontal line here to measure our angle of elevation. And we know that that angle right there will be 46 degrees and 40 minutes. And then it says the angle of depression to the bottom is 14 degrees and 10 minutes. So here's our horizontal, and we know the angle of depression is measured down. So let's draw that imaginary line from the top of the smaller building to the base of the taller building. And this angle of depression is 14 degrees and 10 minutes. And it says the smaller building is 28 meters high, so we can label that. And it says find the height of the taller building. So we're interested in finding this height right here. So notice that we have two right triangles here. And we do know the length of the vertical side of the bottom triangle because we know the height of this shorter building. So we know that the vertical side of this bottom triangle will be 28 meters. Now if we knew the length of the vertical side for the top triangle, we could add 28 plus this other length, and that would give us the total height, which is what we're interested in. But we can't find this value without knowing one of the sides of the top triangle. And right now we don't have any sides for that top triangle. So what we're going to do is use this side from the bottom triangle and this angle to find this horizontal side that the two triangles share, and then we can use that horizontal side and this known angle to find this vertical side. So that's the plan. Let's see if we can pull it off. So we know that we're going to have to write an equation that relates what we know to what we want to know. But in order to do that, we have to give a name to the thing we want to know. And I'm just going to call this shared side W. I called it W for width because it's the width of that triangle. But you could call it anything. You could call it D or A or whatever. It really doesn't matter. I just happened to call it W. Okay, now coming from the angle that I know, I also know the opposite side from that angle, and I'm interested in finding the adjacent side. So opposite and adjacent makes us think of tangent. Let's write tangent of 14 degrees and 10 minutes equals opposite over adjacent. So 28 over W. Now this is almost exactly like what we saw in the last example. So we've got to get that variable out of the denominator. Let's multiply both sides by W, and the W's divide out from the right side, and it leaves us with W times the tangent of 14 degrees and 10 minutes equals 28. Now we want to isolate this W, so let's divide both sides by that tangent value, and the tangents divide out from the left side, and this is what you'll put in your calculator. W equals 28 divided by the tangent of 14 degrees and 10 minutes, and that gives you W is approximately 110.93. Now you may be remembering that they said round to the nearest meter, and I did not do that here, but that's because this side is not part of our answer. Remember, this side is only a tool that we're going to use to help us to find this side of the top triangle, and then we'll add the top vertical side to the bottom vertical side to get the total height. So I didn't round here because I know I'm going to have to use this number in another calculation. So, well, I did round, but not to the nearest meter. So you don't have to keep all the decimal places, but do keep at least a couple extra than what you need to round off to in your final answer. Okay, so I've got 110.93 here. And if you can leave that number on your calculator so that you don't have to round at all, even better. And now let's give a name to the vertical side of this top triangle. You could call it anything. I'm just going to call it Y. Okay, so we know W at this point, and so for this angle that's 46 degrees and 40 minutes, we know the adjacent side and we're interested in finding the opposite side. So we're going to be using the tangent function again. So let's write tangent of 46 degrees and 40 minutes equals opposite, which is Y, over adjacent, which is 110.93. And remember, you've still got the unrounded version of this number on your calculator screen, so just leave it there. And now what we're going to do is multiply both sides by that 110.93, so it cancels out from the right side and shows up multiplied on the left side. So you've already got this number on your calculator screen and it's not rounded. And so now you're just going to go times tangent of 46 degrees and 40 minutes equals 117.57. Now, this is not rounded off to the nearest meter, but I'm about to do that. We can round at this point because what we're getting ready to do is add Y plus 28, and 28 is a whole number. So there's not any rounding error that can accumulate at this point and throw us off. So I'm going to go ahead and round off to the nearest whole meter here. So Y, the vertical side of the top triangle, is 118 meters. And then we're going to add 28 plus 118 to get the total height of the building. And that is 146 meters. Okay, you guys, here we are at the end of another section. I really think that if you will learn to read the problem and visualize what it's describing with a sketch, that it will help you so much. So practice on that. Reach out for help if you need it. And I'll see you guys again for section 3.1 next time. We're going to totally change gears and talk about radians. See you then. Bye now.